So hi, myself ROHITH K MENON from class E2B. So we are going to discuss how higher order ordinary differential equations can be solved and the variations in equations according to the values, changes in values of a. So we can continue. So in mathematics, an ordinary differential equation is considered a higher order if the highest derivative of dependent variable with respect to the independent variable is greater than 1. In other words, a higher order ODE is an equation that involves derivatives of order 2 or higher. For example, a first order ODE involves only first derivative dy by dx. A second order ODE involves the second derivative d square y by dx square. And a third order ODE involves the third derivative d cube y by dx cube, and also so on. So we can check how the variation equations can be done by the changes in values of m. So for distinct roots, if the values changes in values of m, the y equal to c1 e raised to m1x plus c2 e raised to m2x plus c3 e raised to m3x, and so on. So for the distinct values of m, the equation will be like this. And for the same roots, the values of m are same. The equation will be y equal to c1 e raised to mx plus c2 x e raised to mx plus c3 x square e raised to mx plus cn x raised to n into e raised to mx. And the equation for the complex roots will be y equal to c1 plus c2x into cos beta x plus c3 plus c4x into sin beta x e raised to alpha x. Note, the most complex roots will be like plus or minus ai, or plus a plus or minus ib, or alpha plus or minus beta format. Now we can check how the changes in equation happens when the values of m changes. For example, if the same roots and distinct roots are coming in a values of m, the equation y equal to c1 e raised to x plus c2 x e raised to x plus c3 e raised to 2x plus c4 e raised to 3x. Then if the value of m equal to 2, 3, 4, 8, likewise the equation will be like c1 e raised to 2x plus c2 e raised to 3x plus c3 e raised to 4x plus c4 e raised to 8x. Then if the roots are in a plus or minus ib format, like for an example 1 plus or minus 2i, then the equation will be c1 plus c2x cos 2x plus c3 plus c4x into sin 2x e raised to x. So now we can discuss how questions are solved using this method. In first question, you can see y triple dash minus y dash equal to 0. So there is a higher order derivative and y triple dash is the higher order. So we can give d equal to m, then m square minus m equal to 0. So we will get values for m equal to 0, 1 and minus 1. So the equation will be cf equal to c1 e raised to 0x plus c2 e raised to x plus c3 e raised to minus x. Likewise, in the second question also, the y4 dash is the higher order, we can see. So by solving that, we will get the values for m equal to 1, minus 1, 2 and minus 2. There we can see changes in values of m. So the equation will be c1 e raised to x plus c2 e raised to minus x plus c3 e raised to 2x plus c4 e raised to x. The answer will be in this format. Now in the third question, we can see y triple dash is the highest order. So the values of m is minus 2 and minus 2. The values of m are same. So the equation for CF will be c1 plus c2x plus c3x square e raised to minus 2x. The answer will be in this format. So like in the fourth question also, the y trip 4 dash is the highest order derivative and the values of m will be 0, 0, plus or minus 1 and minus 1. So the answer will be in the format c1 plus c2x e raised to 0x plus c3 e raised to x plus c4 e raised to minus x. So I hope all you got the idea to how to solve an higher order derivative, and thank you.